I talk about a lot of things in this presentation, and I have links to some things I've stolen from other presenters, reference notes here at this link. Just goes to my website. It's a list of links. Feel free to go there. I tweeted it in PHP UK, so you can go find that stuff. I work at a company called Etsy. It's the world's handmade marketplace. How many people here have bought something on Etsy before? Awesome. Has anyone sold anything on Etsy before in here? Oh, this is the first time I've given a talk and someone's raised their hand for that. That's so awesome. Thank you. Etsy has about 44 million members, of which about 1 million are active sellers, including this man in the front row, with 26 million items listed for sale as of June of last year. We have people buying and selling from nearly every country in the world. 25% of transactions cross a border, which is really exciting, and we're closing in on about 600 employees across 8 different countries. One unusual thing about Etsy is how often we deploy, and that figures into how we had to use HHVM at Etsy. It's not unusual for us to deploy over 60 times a day, and if you saw the continuous delivery talk earlier, you understand the benefits of that brings you. So that's enough about Etsy. A quick overview of what I plan to cover in this talk. I'll talk briefly about what HHVM is, why Etsy was interested in it, how we migrated, what problems we encountered, what else can it do, and a bit about the future of PHP where we see it. So first, a brief history of HHVM. So HHVM was written by Facebook, and its history goes back to 2009. 2009 at Facebook, they're running a pretty simple stack. Linux, Apache, MySQL, PHP, of course. But they couldn't keep up with their traffic growth. The story I've heard is they could not buy servers fast enough and get them racked to meet the demand that their users are bringing. So that was a big problem. So a group of engineers got together in this sort of daring effort to make PHP more efficient. If they could do that, they could cut down the number of servers they need, and they would need fewer servers to serve the site. And thus was born this thing called hip-hop, which you might have heard of a couple of years ago. What hip-hop did was compile PHP to C++. Facebook would then deploy that C++ binary to all their machines instead of PHP source code. It came with a couple downsides, though, the biggest one being it was tough to ask developers to, on their machines, say, you know what, instead of doing that great PHP workflow you've had all these years where you edit files and you reload the page and the change takes effect immediately, why don't you compile that for a couple minutes beforehand? Didn't go over so well. So after they sort of put the fire out, they said, what could we do to make this better? And out of that work came Hip-Hop Virtual Machine, which is what HHVM stands for. HHVM is not a source transformer. That's now what they call HPHPC, the hip-hop compiler. What HHVM aims to be is a drop-in replacement for PHP. So if you're running PHP in a setup like this, you have a web server, it's talking to a PHP backend over fast CGI, something like PHP FPM perhaps. The idea is you can just replace PHP with HHVM. It talks over fast CGI just like FPM does. HHVM runs anywhere, where anywhere is 64-bit Linux or ARM, strangely enough. And it mostly works. So as of 2013, Facebook was using HHVM for everything. And it's at this point that they made a big push for open sourcing their code. So HHVM is open source. Internal diffs are developed in the open, so when Facebook is considering making a change, an optimization, oftentimes it's a pull request in the public, but it's always a diff that's committed as soon as it's done. It's not as though they hoard up diffs and release them every 6 months like Android does, for instance. It's included in a lot of modern Linux distros. Over 2,000 bugs have been opened and closed since the project started, and over 1,000 pull requests have been accepted. Not only is it open source, it's also used by a lot of big companies already besides Facebook. Baidu, one of the big, if not the biggest search engine in China, all of its products are now on HHVM. Box, enterprise file sharing and cloud content management service, is in the process of moving all of their products over to HHVM. They wrote a blog post about that. And most recently, and most exciting, Wikipedia recently moved all of their web servers over to HHVM. They wrote a blog post about that called How We Made Editing Wikipedia Twice as Fast. In putting this list together, I looked at the Alexia top search results, that weird like spyware toolbar that gets installed on people's browsers. And these are the top 10, at least as of a couple weeks ago. Of the top 10, 3 of those websites are now running HHVM, which is pretty exciting. HHVM is compatible, asterisk, with PHP. Doesn't look like it is at first. If you run the PHP unit tests in HHVM, over half of them fail. But those failures, they're missing extensions, some rare extensions. Oftentimes the error message output is different. The important thing to realize is that 20 of the top PHP projects on GitHub do pass, and 97% of unit tests among the top 50 PHP projects on GitHub pass. So don't sweat the small stuff. Within Etsy, we saw 99% of our unit tests pass. Of all the test suites, we have about 1,800, only 20 failed initially. But what's really cool about HHVM is it's faster. Much faster. Facebook claims you should expect to see speed improvements between 3x and 6x faster than PHP. But this is for Facebook, and there are a lot of caveats on that number. For example, when they wrote this paper explaining this, they were comparing HHVM against the version of PHP they last used in production, which I believe was either 5.2 or 5.3. And at that point, it was impossible for them to run on regular PHP because they were using some special features of HHVM that they had built. So they couldn't do a modern direct comparison. So that number is a little inflated, and there are some other gotchas which I'll talk about as we go through. If you want to learn way more about HHVM and the hack language they developed on top of the HHVM, you should check out this presentation from OSCON last year that Paul Tarjan and Sarah Goldman gave. Talks a lot about the internals of HHVM, the hack language, way more than I could cover. That's also in the notes. So why was Etsy interested? Performance is great, but many companies don't need this performance. About a year ago, I gave a presentation talking about API-first development at Etsy. So what does this mean? We had this problem where we were developing more and more mobile applications, like a lot of companies are. But we also still had this website, and it was all written in PHP. We love PHP. But the API code and the website code were sort of separate. They shared many of the same models, but sometimes if someone was coming along to port a feature to the mobile apps, they would find out that this code is just too tightly integrated into like a web view. I'm just going to copy it a little bit, change some things, return JSON, and that'll be fine. This led to a lot of problems. It made moving features to the mobile apps very difficult. There's feature drift where sometimes a new feature would come out on a product that wouldn't ever get moved to the other. So to solve this, we integrated all of our data fetch into an API. So whether you're using a mobile app or the website, data fetch is being done using an API. So on the PHP web servers, you're curling localhost for the data. Great, we thought we were super clever. This is going to solve all these problems. We won't have this feature drift anymore. Another thing that came out of this that was very similar to the React talk that was given yesterday, we have this concept of bespoke endpoints. So bespoke endpoint aggregates multiple REST endpoints concurrently, then does some munging on the data and returns a view of the data specific for a view. So there would be one bespoke endpoint for the listing page on the mobile apps and a separate one for the listing page on the website. And what this looks like is, so taking the Etsy listing page as an example, we have all of these different domain objects we need. We need a listing. We need the seller who sells that listing. We need some related listings to that listing, overview, some recent listings, and the shop that's selling the listing. So what a bespoke endpoint can do is do some really clever dependency resolution and concurrently fetch all of the objects that it can, and then in a second round of resolution, fetch the other ones. And this is all done using curl multi. If you haven't used curl multi, I respect you because it's pretty terrible. It's a lot of work, but it allows you to do some powerful concurrent things in PHP that are otherwise impossible. And the pseudocode for this is basically put some curl handles into curl and then execute them and then have a busy loop, select out of the curl handles, wait for them to resolve, and then once they're all resolved, you can return the result to the user. So it's only ever as fast as your slowest endpoint you're fetching concurrently, but it can speed up data fetch a lot. Also in the slide notes, one of my colleagues gave a presentation on this at PHP Day in Verona, Italy last year, so you can check out that video if you're curious about curl multi and all the cool things you can do with that. So we thought we were really clever. We have this great way to fetch more data. We're solving a business problem. We're bringing products to mobile more efficiently, faster. We sort of ignored this problem. So this is a view of our home page, and it shows all those bars are separate HTTP requests that go into producing the home page. And because PHP is shared nothing, every time you make an HTTP request, you have to build the world. You have to load your user, instantiate the locale, do a bunch of other work, sanitize input from the user, and at every point you have to do that. So for us, this bootstrapping process takes about 25 milliseconds, but aggregated across all these endpoints, that's 350 milliseconds worth of work on the cluster that's just totally duplicate. The wall time for the user is great. For the cluster of web servers, it's very inefficient. And again, this is because these bespoke endpoints are making multiple concurrent HTTP requests. As a result of this, we saw the traffic on our API cluster grow exponentially compared to our web cluster. This was because developers internally thought this was really cool. They started to use it a lot. They were building all of their new products using bespoke endpoints, which was great, but now we had a problem. Etsy doesn't use any virtualization or cloud providers. We have our own, we release space in our own data centers. This is because web serving at Etsy is CPU bound. At a certain scale, it's just more efficient to have a non-virtualized bare metal machine. And you can do cool things like put 22 SSDs in a 1U unit, like we see here. In our case, unlike Facebook, when we saw that exponential growth, we weren't limited by buying hardware. We were limited by space for it. So we are looking at the possibility of having to lease more space in the data center, which would involve new power supply units, new switches, new routers, moving things, and lots of human time. We have to have humans do this. This is two of our operations people putting in a server upside down and having to take it out, put it back in again. So it can take some time. So we're looking at this and we say, okay, if we can lower the latency average across all our PHP requests, then we can do more requests per second per box. More requests per second per box means we need fewer boxes to serve all of the traffic. But not only that, we're looking at the possibility of having multiple data centers around the world. Currently, we're only in New Jersey in the United States. We were creating one on the West Coast, and there's a possibility that we would have more around the world. So fewer boxes also translates to less money per data center we need to spend to spin one of these up. And perhaps most importantly, fewer boxes is better for the environment. So those were all the technical motivations for why we started to look at HHVM at Etsy. There's one non-technical one. I found myself in beautiful Dublin, Ireland, separated from my team in New York, 5-hour time difference. And my manager said, go do something crazy. You got 2 weeks, see what you can come up with, just try something. Also, Dublin doesn't usually look this beautiful, it usually looks a little bit more miserable. So I spent a lot of time indoors as it rained. So how? I'm lucky enough to work with a lot of really smart developers at Etsy, including this guy, who you might recognize. Rasmus. Rasmus had already played around with HHVM. We had already been using it to do static analysis in our tests. So calling a function that doesn't exist, creating a variable that's never used, things like that. So I said to Rasmus, hey, do you have a build of HHVM I can use? It's like, yeah, just copy it down. He had already compiled it, so I just grabbed it. And I got to work on my virtual machine trying to run etsy.com on HHVM. Loaded up the page, totally blank. Look at the error log. Okay, got some missing memcache constants. So we were using memcache constants that HHVM didn't define. Doesn't matter. I'll comment those out for now. So no memcache for this prototype. Fine. Missing the GeoIP extension. GeoIP is something you can use to look up where a user is based on their IP address. That extension wasn't built into HHVM. Comment that out too. We don't have any user analytics. That's fine. Message pack extension was missing. The message pack is like an efficient binary serialization format. Well, login doesn't need to work for now. Signed out only, etc. And so on. Although I went back and checked the diff I had to make to have HHVM run, it was 4 lines had to be commented out to get etsy.com to run on it. So that's pretty good. Well, to get the home page to render, rather. So at this point, I had it running on my developer virtual machine, and I ran some benchmarks. It's on a virtual machine, so the benchmarks are, you know how it is. But it was faster. Way faster. Non-scientific, but way faster. So I sent an email to my manager. Here's like a gist of some numbers. It's like, whoa, wow, really? What would the next steps be? Let's do this. Let's try it out. So the next step would be to go back and fix all the things I had commented out. And that involved making changes to HHVM itself, which I did see in college once. But adding some constants, that wasn't too bad. Submitted that pull request that got accepted. They're very responsive. It's at this point I'd like to call your attention to this graph that I realized I had. This is my happiness as a developer in orange graphed, my happiness as a developer in orange graphed against the performance of HHVM over time. So something terrible is about to happen. Currently, we're at this high. You're in that point when you're making something and you wrote it and it worked, it does what you thought, and you're like, I'm unstoppable. Nothing will stop this project. I'm going to be done in 2 weeks. We'll have everything running on HHVM. It wasn't that simple. So made the change. I did it in an Ubuntu virtual machine, but we run a different Linux distribution, so I had to compile it for our setup. How hard can it be? Rasmus did it. What follows, I looked through my emails, and we have a daily email stand-up where we say what we did and what we got stuck on. So I looked through and I pulled some quotes from this time. On September 2nd, I told everyone, I've started to compile HHVM because we need to do that to fix these things. Fast forward 2 weeks, and now I'm down to the point where I'm S-tracing CMake to figure out why HHVM won't build. This is the doldrums. This is where I am. I thought there is no way I'm going to get this to work. I'm so out of my depth. Can't figure this out. Turns out that make clean is written by a human, and humans can make mistakes. If you really, really want to remove all build artifacts, this command is great. It removes everything that wasn't cloned, basically, including things that are git ignored. So the problem I had at this time was make was generating objects and was not deleting them. So when I was making changes to fix things, it was ignoring them. September 24th. This was in all caps in the email. Got it to compile. I was so happy. Now we're back at the top. Now it's going to be just 2 more weeks. We'll get it this time. The next day, I had already built an RPM. I'd never built an RPM before in my life. And I thought I was really clever. So yeah, at this point, we're feeling really good. The reason I thought I was being really clever with the RPM is because RPMs have this idea of dependencies. So if you have a package and it needs other things, you should have other packages that provide that thing. So when you install that thing, it installs all the dependencies. Dependency management. Very easy computer science problem. But I thought, I don't have time to deal with that. I'm just going to copy all the dependencies into the RPM, and ship that. It'll be really big, but who cares? A week later, I sent out an email explaining how I had broken every machine in production by installing this RPM because it provided everything to everything else. So don't do that. And so the real problem here is all this 2 months worth of work, we were running CentOS, which is fine. CentOS is a perfectly respectable Linux distribution. But we were running CentOS 6, which is fine. That's a perfectly respectable, stable enterprise Linux distribution. But Facebook, they like to use the newest versions of everything. Because in their perspective, why should we limit ourselves to using old tools when we could use new things like C++11? So in order to install HHVM in Cent 6, I had to upgrade all of these packages and more. And if you've ever tried to upgrade libc, don't try. I gave up. The answer, upgrade to Cent 7. Then you only have to upgrade 3 or 4 of these things. Much easier. OK, so now we have, finally, a version of HHVM with my fixes applied. We have it in production, or we have it able to be installed in production. Now we can run a more rigorous test with this prototype. I'm going to quickly talk about how Etsy, as a product engineering organization, thinks about running experiments. This is Dan McKinley, and he gave a talk at the Lean Startup Conference last year about how experimentation works at Etsy. And he walked a little bit through the history of doing experiments at Etsy. So at first, this was how it worked. You had this idea for a product. And you thought it was great, so you built it. You wouldn't have built it if it wasn't a good idea. And then you release it because it was a good idea. Of course, everyone should have this thing. But eventually, after you do this, you realize that maybe your idea wasn't perfect, and you look at some of the numbers and realize that no one's using your awesome project. So out of this comes A/B testing. A/B testing is this idea that you have one version of a page and another version of the page, and you can compare metrics between them as users use those products to figure out which one's performing better. But even here, A/B testing didn't solve the problem. What this often turned into is you have the idea, you write the code, and then you A/B test forever because it turns out the assumptions you made about the project were totally wrong and it's never going to perform well anyways. So enter this new idea of doing experiments. You have the idea, you validate the idea. You do the cheapest thing you can possibly do to make sure it will work. Then you make a quick prototype, run some A/B tests with that, validate some more ideas, continue to refine and run A/B tests until you end up with a more full-featured product that your users will actually enjoy. And the important thing to point out here is that the prototype is possibly quite crappy, and that's OK. So for us, this thing on my VM with all these things commented out, that was the validation. It validated that it was pretty possible to run Etsy.com on HHVM, and it wouldn't be too crazy. So the prototype phase is now where we're at. We've solved some of the basic problems. Let's run an A/B test. Later on, we can refine it and make it less crappy as we encounter problems. So again, validate, can HHVM run Etsy.com? Yes, we think it can. So the prototype, our goal was, is it faster? We were pretty sure it was faster, but we ran the benchmark on a VM. All sorts of crazy things can happen on VMs to affect numbers. So we wanted to test it more rigorously. And throughout, from this point on, I'm going to discuss some of the problems we encountered that we didn't filter out in the prototype phase, or in the validation phase. And real quick, scoping. Going back to this graph, we decided that it was more important to get the API cluster running on HHVM than the web cluster because of this graph. So we scoped ourselves, let's just move the API code over to HHVM, not worry about anything else. So I installed HHVM and PHP on a production level box. This is a pretty beefy computer, 32 cores, lots of memory, and ran some synthetic benchmarks. And it looked really good. So I had about a dozen API endpoints I verified by hand. You can probably even barely see HHVM in green down here. So this is response time as load increases. So I ran Apache Bench with 10 requests per second, 30 requests, 50 requests, and so on. Because what we were looking for here wasn't just performance. We were looking for throughput. Throughput was what was going to help us use fewer boxes. And we can see around 180, 190 requests per second, our Apache and PHP 5.4 setup just totally, the performance at that rate was unacceptable. HHVM was totally fine. Kept cruising. Great. So we verified that, yes, it is faster. This will be a thing that will help us. And now I'm feeling really good. We have this thing installed. It works. I verified my assumptions. What can possibly go wrong? So now let's run an experiment. Time to fix the problems we skipped. So how do we gain more confidence from this point and also validate our hypothesis that this would help our throughput on Etsy.com? And we came up with a really interesting solution, T'ing traffic. So you can think of T in this case like the T on the command line. And the way this works is we have a load balancer that's distributing load between our web servers. From that load balancer, we wrote a rule that said if an API request comes in, send that request to the API cluster and to these other two clusters. So copy it, duplicate it, send it to the API test and the API HHVM cluster, take the response from the normal cluster and throw away the other ones. This allowed us to see real-world production traffic against our boxes, not a synthetic test where you're just sort of hammering it with Apache Bench. What happens when real users use it? And a couple things we learned at this point. First, infrastructure experiments are hard. On the product side, you can make a change to your website, set up an experiment, and run it. For us, in infrastructure, it's a little bit harder. We need to make sure that we had the same hardware everywhere, because if we didn't, it would invalidate all the performance results. We need to make sure we had the same traffic profile. If one box was receiving traffic that just was doing more work, was causing more things to happen, we also couldn't compare the traffic that box was getting against another one. And we needed the same hacks present on both. So at this point, we still had some HHVM issues we were working out, things we had sort of commented out. We needed to comment those out in PHP as well. So what this meant was both machines had a read-only MySQL interface so that if a user submitted a post and we duplicated it 3 times, it didn't happen 3 times, it only happens once. Same with Memcache and Redis. We had IP tables blocking almost all the things, and we weren't forwarding any logs to syslog or logstash. So back to this graph real quick. This was a bit of a slog. It was a lot of work to set up, to convince everyone on my team that this was a fair experiment. There's a lot of momentum behind PHP and mod PHP at Etsy. But eventually we got through it, and it looked pretty good. So this is comparing HHVM CPU serving production profile traffic and Zend CPU, or PHP 5.5 now, for 14 hours. Peak was about 140 requests per second. And note that this is on fairly powerful hardware, like I said. But here we are seeing HHVM performing about twice as well as PHP 5.5. But remember, Facebook said between 3 and 6. What's going on here? There's a couple things that could be happening. First is we try to make our API as light a wrapper around MySQL as we possibly can. This leads to, we don't want as much overhead. We want to eliminate as much overhead as we can. But neither HHVM or any other PHP language technology will speed up your MySQL queries. So that could be a reason why. It just wasn't doing that much computation in PHP. Also, we weren't doing all the optimizations that the HHVM team recommended. There's this other feature they have called a repo authoritative mode, which they claim will give you an extra 20% speed improvement on top. And basically what this does is generate a bytecode SQLite database, so sort of like opcache, but in SQLite in advance. So you have a compile step now. It builds out an include map between all your classes, statically resolves file paths, and does a lot of other optimizations. But we couldn't really use this. To introduce a compile step when we're deploying 60 times a day would have been too complicated. And 20%, we were already seeing 2x is perfectly fine. Yeah, we'll take it. But I mentioned before that we had these hacks in place not to do data access. So how do we verify writing data? And this was a big concern, because if HHVM has some weird bug where it writes the wrong data in. Now we have data corruption in our database, and no one wants that. So we solved this by doing employee-only traffic. And here's where we encountered some really fun problems. So employee-only traffic, the clusters have minute load. It's like not even showing up on the CPU graph, because there's only a couple hundred people using them. So it wasn't testing performance, we were testing correctness. So memcache. We noticed some problems with memcache. We have a rate limiter in our API, and we noticed that it couldn't decrement any of the keys. It was always saying that the key couldn't be found. So we try to reproduce it. We install HHVM, we set up a local memcache, call decrement, works fine. This was a slog. I'm getting a little bit depressed here. Turns out there's a bug in HHVM's memcache extension with decrement. It wasn't deferring to the right function. So we submitted a patch, have it defer to the right function. Everything's great. While we were debugging this, we happened to TCP dump the connection between HHVM and memcache. We noticed something else really strange. Actually, everything was returning false, even after we made that change. Every get was returning false. Okay. What could this possibly be? Turns out another bug in the HHVM memcache extension. Just to be clear, HHVM requires different extensions than PHP. It has a different extensions API. So if you want to use an extension, you have to port it over to this new API. So the extensions are different between the two runtimes. What was happening here was, in memcache, you can set a hashing option, like, when I send you a key, hash it this way. And it was resetting that on every time a request happened. So we would set it, it would say, great, this is the new hashing way. It would do it once, and then it would throw it out. So fix that. Now our memcache is working. So the takeaway here is, HHVM is rock solid. Throughout this whole migration, we've found exactly one language bug. A weird thing with get last error, or error get last. Turns out that in PHP, error get last pops or pulls the last error off of the stack, and so if you call it a second time, that's not there anymore. HHVM kept it around. So that was a little strange. But other than that, we expected to find all of these incompatibilities. We thought Etsy has some weird edge cases in our PHP code, and it's going to trip HHVM up. We're going to spend a lot of time trying to figure it out. Wasn't the case. However, extensions sometimes have bugs in HHVM. Many extensions in HHVM Facebook doesn't use. They wrote them specifically so they could open source HHVM. This is because in a lot of these cases, Facebook has their own custom clients. So they have their own custom memcache client. They have their own custom MySQL client. So they don't use the extension that talks to libmysql or libmemcache. However, just last week, they did open source both of those things, and the extensions for those libraries are now in HHVM. So if you wanted to use those new clients, then I believe you would be using the same extensions as Facebook. So don't expect the MySQL and Memcache extensions, or frankly, any of the extensions to be thoroughly battle tested if they're not used by another company that's already using them. So we did this employee-only traffic. We're feeling really confident. No one has reported any bugs internally. Requests are looking very consistent. We were able to diff the requests between both environments. So now we start the slow ramp up. This is the traditional part of an infrastructure experiment where you say, I'm going to have 1% of traffic served out of this new thing, and then 2%, and then 5%. So we got pretty far. I think we were up to 20, 25%. And then one of the operations people PM'd me, and he said, hey, Dan, do you know why HHVM sometimes, it's generating these logs that are failing to be parsed when we send them to Logstash? I was like, wow, that's weird. And being an ignorant American, I was like, why is there a V after that, Jan? And why is it lowercase? Then I noticed something even weirder. It's like, oh, okay. Why is there non-ASCII characters in our log lines? So we talked with some of the people. It was actually Erasmus who keyed us into what's happening here. HHVM is threaded. And we do localization at Etsy by calling setLocale. SetLocale is a PHP function. It sets the locale. And then when you call string format time or any of those other formatting functions, it will use the internal locale libraries to print out the dates and things like that. So what was happening was a request would come in. It would set locale to something, say Dutch. It would go through and it would do some work. It's loading things from the database, calculating some stuff. Another request comes in. It sets locale to Russian. Now the first request is done. It's ready to print stuff out to the user and the logs. So it calls string format time with Russian, not with Dutch anymore. How is that possible? Turns out HHVM is a threaded SAPI. And if you look at the PHP.NET documentation for setLocale, there is a warning there. If you use IIS, be aware that setLocale will affect all requests. Turns out that HHVM and IIS have the same way they handle requests. A request isn't handled by one process at a time. It's handled by one thread at a time. So if you call a function like setLocale, which it turns out just proxies to the system call setLocale, it affects the locale for the entire process and all of your requests that are happening at that time. Pretty surprising. So there's a solution. There are thread local versions or equivalents of setLocale. New locale and used locale are some of them. And there is a pull request we've submitted to HHVM to use that, so we didn't have that problem anymore. So the takeaway. HHVM is threaded, and threads are hard. This can cause surprises with certain functions. So any function you have that you use in PHP that closely resembles a system call, be very careful when you're using that in HHVM. It might have side effects. PHP was written by a C programmer. It has a lot of C semantics in it, including if you call setLocale, obviously, you're calling setLocale, the C function. Also, though, be careful about what libraries you use with HHVM, because if any of them call setLocale, then they are also affecting all the threads because it's all included in the same process. So we figured that out. That took a couple weeks, and now it's time to release. So let's continue on the slow ramp up. This is my favorite graph. It shows 2 HHVM boxes slowly eating all of the requests per second from all of the other boxes. They're just like, give me more and more and more, I can take it. So over this time, these graphs are a little wonky, I apologize, because the y-axis is not consistent. Thank you very much, Ganglia and RRD tool. But things are looking way better. Perk 95 is looking especially good. And this is only on our internal API, which is what the bespoke endpoints fan out to in our earlier example. So this is a nicer graph. HHVM is faster. Now, after we have memcache working, that was probably one of the reasons why we didn't get a 3x. And a couple other things, it's looking closer to 3x than it was before. But performance isn't the only great thing about HHVM. It is a definite benefit. It is a thing that gets you in the door. But I think it has a couple other features that will cause you to stick around. So what else can HHVM do? One great thing it can make is flame graphs. Flame graphs are something that are typically used when you're profiling on a CPU. So a flame graph shows you what instructions happen on the CPU what percentage of the time. In HHVM's case, it shows you what PHP functions occur in stack traces what percentage of the time. So this isn't necessarily a graph of what functions are taking the most time, but they are sort of the most called ones. And this is very valuable for looking at where you can focus your efforts to make performance improvements. This is enabled by a project that Wikipedia put out called ArcLamp. They wrote this great tool chain to take information from an extension Facebook wrote for HHVM called Xenon and to produce these graphs. So if you check that out, it's also in the notes. Very cool. HHVM also comes with its own debugger. How many people have used Xdebug? How many people have tried to get it set up and have failed and then sort of given up? Yeah. I love Xdebug. I love debuggers. They're so great. But I don't know about the rest of you, but oftentimes I destroy laptops or accidentally nuke a VM, and I didn't back up my Xdebug config, so I'm going back in. I'm IDE keys and these extensions and Vim plugins and blah. Such a hassle. HHVM comes with a debugger built in. If you like GDB, you're going to love this. This might be a little small, but I'll try to walk through what's happening. I did not do a live demo, but this should play a video. Maybe. You can do it. Man, even video live demos don't work. Wow, that is surprising. I can't even change the next slide now. What happens if I click here? Fundamentally surprising. Okay. If I close this and then manually go to the next slide and press play. Okay. Want to try it one more time? Let's see. Oh, I saw the square change. Yes. Okay. So you connect to the virtual machine, and it lists a couple different virtual hosts you have running. You attach to one of those, and this is very similar to GDB if you've ever used this. It's all command line based. You get this great help menu. It has lots of features. You can step through stacks. You can step over things. You can continue things. You can look at frames. You can look at globals. So this is me scrolling through trying to figure out what I should do. So I'm going to set a breakpoint in our code right in the opening function of our API, the API handler. I'm going to set it on line 163. So all you do is type the name of your class, colon the line, and it sets the breakpoint. Really great. Type continue. I'm going to flip over to my terminal and make a curl request, which I forgot to enlarge the font on, but it's OK. Trust me, I made a curl request. Now we go back, and it has hit the breakpoint, and it prints out our source code right on the bottom there. We can look at the local variables in that frame. We can print out the global variables as well, which I think I forgot how to do, so I press help and I scroll back up to see how to do it. So yep, there's the local frames, there's the global ones. We can step over things, we can continue, and it's all built in. And one of the cool features of this is, who here has ever had a problem that only happened in production, could not reproduce in dev? Oh, wow. That might be the highest number of hands raised throughout the day. Right, we've all had this problem. With this type of debugger, you can set a conditional breakpoint. So if you have a problem that only happens in dev, but you can reproduce it when you, or in production, or you can reproduce it when you're using the website, you can set a conditional breakpoint on your user. So the breakpoint will only trigger if user ID equals your user. And then you can step through on a production server. All the other threads will continue to serve requests. So that's a really powerful tool. This isn't part of HHVM. It's a separate project, but it uses the HHVM parser and its ability to produce an AST, an abstract syntax tree. That's tough to say. I have no idea how to say it. It could be PFFF. It could be don't know, but it's really cool. So it's a suite of tools, and one of these tools is something called sgrep, and this is syntactic grep. So sgrep doesn't work on the token level of source code like regular grep does. It works on the abstract syntax tree. So it doesn't care about distinctions between, does this function name have a space between the function name and the open paren? Is the argument list separated across multiple lines? All of that gets put into the AST, and it's all the same to sgrep. So for example, if you wanted to find all invocations of foo, where the second argument is 1, with any number of arguments after it, and think about the regular expression that would be required for this. Yeah, and then think about spaces between function names. What happens if a developer split the argument list across multiple lines? It can get crazy. With sgrep, this is really easy. You pass in this expression, find me all calls to foo. The first argument can be anything, the second argument has to be 1, and there can be any number of arguments, 0 or more after that. Really powerful. Find all ampersand operators where the left and the right-hand side are the same. The regex for that, I think it involves that like back calls or whatever that thing, reverse lookups. Yeah. sgrep, this is really easy. Find me anything where the first thing is something and an and then the next thing is the same thing. You can even use the pvar option to print out all those values. Not that anyone would hopefully ever actually write code like this, but you could see where something like this would be powerful. So again, find all calls to foo, the first argument is 1, very simple. Find all method calls, add preparable with any number of arguments. So a method call is different from a function call. A method call happens on an object. So here you just say, grab me an object, and if it has add preparable called on it, with any number of arguments, show me where that is. And the arrow can be on the next line, it could be a chain. It's really great. But wouldn't it be even better if we could, like finding source code with the HHVM AST is really powerful. But what if we could change source code with the HHVM AST? What if we could write a refactoring using the AST and it would take place across our entire code base, doesn't matter how the source code is written? Enter spatch. So spatch is syntactic patch. And this is dark magic. So say we wanted to remove the second argument from all invocations of function foo. This would be terrible. There's probably some sed command that would get most of them, but you wouldn't really, in your heart of hearts, you wouldn't really trust that you did it right. So you would still have to manually test everything. With spatch, this is really easy. So just like a regular patch, find foo, get the second argument, get the first argument, take the second one, delete it, and close it off. And this will make that change across your entire code base. So spatch, you just run that with a patch, and you can even do things like rename a function with any number of arguments. It's just this, minus foo, replace it with bar. Really cool. So that's the PFFF tools. This is a separate repo. You don't need to use HHVM to use these tools. You just need to install it, and it will use the parser internally. This is hot off the press. I figured out how to do this yesterday. Anyone used the Linux tool perf before? Tried to. Yeah, me too. So perf is something that shows you, at least the way I was using it, I've only started using it this week, what percent, for each function, usually C or C++ functions, what percentage of CPU instructions are caused by that instruction command. HHVM, it turns out, writes PHP functions into memory just like C and C++ functions, which means that you can use perf to see what function calls are taking the most time, the most CPU time in your application. This is really powerful. I couldn't log into our web servers to get a bigger view of this. So this is what it looks like. I'm going to try to zoom in here. So here we see this. This thing, HPHP fsort, this is the HHVM implementation of sort. And we can see it's taking 12% of the CPU time on the left there. And if you drill into that, you can see what PHP function is calling HHVM sort. So in our case, it's part of our DB connection class. And so here is a much bigger, simplified version of that. 12% of CPU time is spent calling HHVM's implementation of sort. And that is triggered most of the time. It shows percentages. So in our case, 99% of the time by that function name. 12% of CPU time. If we can cut that down by half, that's a measurable win on our throughput. So lessons learned, just to recap. If you're running an old operating system and you want to use HHVM, you're going to have a bad time. Teeing traffic is a superpower. It was very powerful to just spin up HHVM, throw some traffic at it, see what breaks, and not worry about breaking our experience for our users. HHVM is rock solid. Extensions sometimes aren't. This is rapidly changing. Like I said, Facebook just open sourced some of their implementations of internal extensions. Wikipedia and Box and Baidu are all using HHVM, so this will change, but just be aware for now. Threads are hard. Be careful. HHVM is threaded, not process-based. Watch out what functions you call, what extensions you include, what libraries those extensions include. And tooling is very powerful. Tooling, we saw in a couple of presentations so far, tooling can be the difference between something that your brain can't understand and something that it can. So do run a newer Linux distribution. Do ramp up your HHVM migration slowly. Don't trust that extensions are 100% good. And don't assume that processes are like threads, like I did. A real quick aside on the future. Who here was at Sunshine PHP a couple weeks ago? Anyone? Rasmus gave a great talk on the future of PHP. This is a graph of PHP 7 performance over the past year. It's been getting better and better and better. It will continue to get better. He benchmarked PHP 7 against past versions of PHP and HHVM. PHP 7 is super competitive, sometimes even better. So PHPB, it's better. MediaWiki, HHVM comes out ahead, probably because the HHVM team spent a lot of time optimizing for MediaWiki. So OpenCart, again, it's sort of neck and neck between these two environments. So what does the future hold? No one knows. But we are able to react more quickly now. We have a foot in each of these, and we are better prepared to react. So this sort of PHP performance arms race is going to be great for everyone. It's going to be great for PHP users. It's going to be great for HHVM users. I'm really excited to see what's going to happen the next year. Facebook has already announced changes they're making to their just-in-time compiler next year, including using LLVM and some memory optimizations. So I'm really excited to see what happens here. This was not just me. After I got back from Dublin and dried off, a lot of these people helped me at Etsy, and special thanks to the Facebook folks who took a lot of time out of their day on IRC, on email, in person, especially Sarah Goldman, Paul Tarjan, and Josh Watzman. They're great. The HHVM IRC channel on Freenode is super responsive, and I've learned a lot by hanging out there. So thanks to all these folks, and I'd be happy to take any questions, and please, I love feedback. Thank you.
Hi, you said you're using both now.
Yep.
Have you switched mostly to HHVM, or are you still running more servers in PHP?
Our internal API cluster, which is the cluster that those bespoke endpoints fan out to, which is where we are seeing the most growth in our requests per second, is HHVM, and we have not begun to transition any of the other services yet. But it's something we're looking at. We're also sort of hedging our bets with the PHP 7 thing, because that might prove to be an easier transition, especially as it turns out that our web servers that create the website, they use some other extensions that might be a little trickier to compile for us. So we're a little bit hedging our bets, but I would say in the next year we'll definitely have made a decision and gone one way or the other, because we don't want to have to lease more space in the data center.
Hello, I would like to ask if there's feature parity, like language feature parity between HHVM and normal PHP, because although hip-hop did not support namespaces, for example.
Right. I believe, we don't use namespaces at Etsy, but I believe that HHVM does support namespaces. HPHP does not. The old HPHP compiler didn't. And aside from that error get last, we haven't found any language level incompatibilities between our code base and what HHVM can run. And as they showed up there, a lot of the top projects on GitHub run HHVM just fine. Even those failing unit tests are usually minor things. So yeah, in our experience, it's very compatible with a PHP code base. Yeah. So it's our Etsy seller. Hello.
Did you do any other experiments with other language stacks before you did proof of concept in HHVM?
Other languages besides PHP? No. So Etsy is very boring technology-wise. We've used PHP and Apache and MySQL forever. And not only that, we don't use any services. Everything is on one repository. This gets us a lot of benefits as well as some downsides. But the benefits we want to keep are, it's easy for a developer on any product team to move between any other, whether it's a back-end sort of data analysis and collection thing or a front-end product like the home page. They can jump between. This is great for happiness. People can get a lot of variety in their work. It's great for debugging. If you're on call and you're on the back-end data analysis team and there's a homepage bug, you're not totally sunk. So we do not want to move off of PHP. We love it. It has a lot of great scalability benefits that it enforces on you. We use a lot of Scala and increasingly a little amount of Go to do a lot of piping between things. A lot of logging stuff is in Go. We use cascading and scalding for data analysis, but all of the product development is done in PHP. Any other questions? Thanks so much.
No, thank you very much, Aaron.